Okay, third and last video for our rules for differentiation notes, and this one actually isn't another shortcut rule like the previous ones have been. This is kind of going deeper into derivatives in general. So at the top of this last page, in this section, it says second and higher order derivatives. The first derivative of y with respect to x is denoted y prime, f prime of x, or dy dx. All right, we've used these different notations briefly so far for our derivatives. The second derivative with respect to x is denoted y double prime, f double prime of x, or, and I just read that one as the second order derivative of y with respect to x. Okay, so second derivative is an example of a higher order derivative. We can continue to take derivatives as long as they exist using the following notation. Okay, so this idea of this iteration of, hey, you've got the derivative of a function. Well, what if we take the derivative of the derivative? What does that give us? Well, we're going to call that the second derivative. Well, what if we take the derivative of the derivative of the derivative? We call that the third derivative, and so on. All right, so notation that follows. You guys can read this table here, and it kind of goes through and gives the notation for each of our different types of derivative notation that we use, as confusing as that may be. And just notice for the y's and for the f's that we use the prime notation up until 3, and then after 3 it just gets cumbersome, and so we use the number of the order of the derivative in parentheses in that superscript. Unfortunately, it looks like an exponent. The parentheses are there so that we know it's not an exponent. Okay, we're talking about that nth order derivative of y. Again, another example of this notation that is similar to something else that we use. We're going to have to use context to make sure that we do the appropriate understanding in the appropriate context. All right, so then our dy dx and our ddx notation, they don't even use the parentheses, and so it looks even more like exponents. But these are not exponents. This is just the notation used to let us know what order derivative we're taking. Okay, so we're not raising here on that fourth derivative, we're not raising d to the fourth power and x to the fourth power and leaving out the y and the d in the denominator. This is just the notation used to denote the fourth order derivative. All right, how are we going to use this? We'll do one example together, and then I'll leave the others for you to do on your own and check your work. Okay, example 10 says, find the indicated derivative of each of the following. In part A, we've got the fourth order derivative of this given function here. Okay, the given function is already in this standard form where we've got individual terms, right? Polynomial in standard form, which is nice because we can take each term one at a time and we can apply the power rule to each one. Now, this function in square brackets is the original function. This is f, okay, or y. So we need to go one at a time and find the first, second, third order derivative in order to find the fourth order derivative. Okay, so go through, find your first order derivative, one term at a time, boom. Now we're going to take the derivative of that. So take the derivative of this negative 40x to the 7th term, 12x to the 5th term, and so on. There's our second order derivative. So now we're going to take the derivative of the second order derivative, which will be the third order. Okay, that gets down to 3 terms. Now we take the derivative of the third order to get our fourth order. And now because there's a constant on the end, derivative of the constant is 0, so we're down to just 2 terms there for our fourth order derivative of that original function in the square bracket. Okay, so just multiple iterations of derivatives to find higher order derivatives. Practice that in part B. You're going to have to use the quotient rule. Be careful with those. And then in part C, they don't give you the original function, so be careful about how many derivatives you take on that one.